Hello everyone, I am Trupti Pandya from Mahatma Gandhi Institute of Technical Education and Research Center Navsari from Civil Engineering Department. Today's topic is Introduction and Concrete Making Materials, which is a part of concrete technology subject which is offered in BE3 semester 5 civil engineering students of Gujarat Technological University. This subject involves introduction to concrete, fresh concrete, hardened concrete, concrete mix design, special concrete, and some destructive and non-destructive testing on concrete. Total, there are 8 modules in concrete technology subject. Let's start with module 1, which is introduction, history, advantages and disadvantages of concrete, and module 2, which is concrete making material. So concrete is most commonly used building material. Concrete is a mixture of cement, fine aggregate, coarse aggregate, and water, and sometimes admixture. It is very strong in carrying compressive strength and extremely weak in tensile stress, right? Because these material, sand, cement, aggregate are good in compressive strength, but they are weak in tensile strength. So that's why concrete is strong in compression but weak in tension. Now the strength of concrete is depend upon the quantity of its ingredient. Not only, it is also depend on the mixed, placed, compact and cured. The strength of, as all we thought that the strength of concrete is depend on the strength of the material or the ingredient like sand, cement, aggregate. No, the way the concrete mixed, the way the concrete placed on site, the way it compact and cure, these 4 processes impart or play important role in gaining compressive strength of concrete. So the strength of concrete is not only the strength of the ingredient but the process by which the concrete is to be placed at particular component is important. Now, as all we know, there are two types of concrete, or we can say that PCC and RCC. So if reinforcement in concrete, reinforcement means steel bars. If steel bars are inserted in concrete to resist what? Tensile strength, then the concrete become reinforced cement concrete. And without steel, simple the sand cement aggregate water mixture, it is known as plain cement concrete PCC. So concrete is used everywhere in civil engineering construction, starting from simple element of buildings say slab, beam, column, walls, footings, and other structures like water tank, retaining wall, staircase, electric poles, piles, dams, everywhere. So from this simple building to high-rise building and any type of civil engineering construction work, concrete is used everywhere. Let's start with the history. So the concrete history start from the Roman Empire. As we know, they are having very nice structure, but At that time, at that period, it is that name was not concrete. In ancient Rome, they accidentally discovered silica and alumina minerals on Mount Vesuvius, and this discovery began to influence and alter the character of Roman construction. But day by day, after the fall of Roman Empire, the quality of cementing material decreases rapidly, and this discovery become lost. The second turning point in the history of concrete is in 1499 AD. Fra Giocondo used pozzolana cement to build the pier of the Pont de Notre Dame in Paris. So, from Rome, now the pozzolana cement was found in Paris, which became the first modern use of concrete. Then in 1824, an English bricklayer named Joseph Aspdin learned that burning finely ground chalk with divided clay in a lime kiln produce a cement. Means some advanced technique is used in making cement. Previously it is simply limestone used. Now in 1824 they use chalk and clay in manufacturing of cement. So this is the third turning point in the history of concrete. Then technology advanced in 1849 in America. Use of iron mats with concrete is made to build the garden pots and tubes. So we can say that RCC was born in 1849, right? And then after the Portland cement became the focal point of concrete technology, and many scientists and engineers turned their focus on it. This is the brief history with their turning point years. Otherwise we can write down 10 or 100 pages on it, right? But briefly we can say it starts from Roman Empire, and then in 18th century advanced techniques were found in manufacturing of cement and RCC. The next topic is use of concrete in structure and types of concrete. As we have already discussed, concrete is used widely in civil engineering construction, in domestic, rural, commercial, recreational, educational construction. Community around the world rely on concrete as a safe, strong, and simple building material. This is the basic property, or we can say good property of concrete. It is very safe, it is simple building material, and strong enough. Concrete is used in many types of civil engineering structures such as building, bridges, dams, plates, cell structures, etc. everywhere. Now, let's see the classification and parallelly their uses. There are that categorized in different ways. So, first classification is based on ingredients present in concrete. Two types: normal concrete, special concrete. Again, it is very simple. Normal concrete has the ingredients, namely cement, sand, aggregate, and water, mixed in some proportion to achieve concrete of desired strength and property. So the known ingredient, the simple method by which concrete is made, and that concrete is known as normal concrete. Then what is the difference between normal concrete and special concrete? So special concrete has additional components other than these ingredients, and that component is known as admixture. Admixtures are added to concrete to achieve special properties like ultra high strength or resistance to tensile forces. So, one more ingredient is used in special concrete. So, this is the classification based on ingredient. Next, based on strength. Concrete can be classified as ordinary concrete, standard concrete, high strength concrete. This column number 3 is designation of concrete and characteristic compressive strength in last column. Now this designation is very important. For that, let's see this slide. Concrete is designated through 28-day standard cube compressive strength. So before placing the concrete on site, the same proportionate concrete is tested in laboratory. How? They mix that material and cast in and prepare a cube. That cube is of 150 mm size each. Cube is cast, cured and tested in compression testing machine, and the concrete designated as M25 has 28 days characteristic standard cube strength of 25 megapascal. So let's see, M10 in ordinary concrete first grade or concrete named as M10. So M is for mix, M for mix, and 10. This value, 10 value indicate the characteristic compressive strength of that concrete at 28 days. Same 15, M for mix, and for this concrete 15 Newton per mm square is characteristic compressive strength at 28 days, right? So three types: ordinary concrete grade M10 to 20, standard concrete grade M25 to 55, high strength concrete grade M60 to 75, right? Now where it is used: ordinary concrete M10, M15 grade concrete are used in pervious concrete. Aggregate quantity is very less, coarse aggregate quantity. Then mortar also in plastering work, right? Then that strength is very less. Standard concrete, that M25, 20, 30 grade concrete is used in building construction of beam, column, foundation. Higher grade concrete is used in mass construction like bridge, dam, right, high rise building. Its strength or load is very high and mass concreting work is required, right? So there are three types: ordinary, standard, high strength concrete based on strength. Then advantages of concrete, right, we can write down in simple manner that the concrete is having higher compressive strength, weak in tension, easily mold. So technically we can write down this advantages like low life cycle cost. Life cycle means starting from the production of concrete to placing and maintenance. Throughout its life, the overall cost of concrete itself is very low compared to other building material except the cement cost. So cement is the costliest material in concrete making, but it occupy only 25 to 40% of total volume of concrete. So it does not much affect the life cycle cost of concrete. So it is cheap. We can say that the overall cost of concrete compared to other building material is less. Second, moldability. So initially the concrete is in plastic stage so that it can be cast into any shape. So plastic stage means when we mix aggregate, sand, cement and water, it is like slurry type. So that slurry, that concrete at initial stage, you can mold it in any shape because in it is not hard, राइट तो आप कोई भी शेप कोई भी कंपोनेंट में आप कंक्रीट को डालना चाहते हो एट द इनिशियल स्टेज आफ्टर मिक्सिंग यू कैन pour concrete and that particular section, then it get that shape, right? So moldability is the most important point of concrete. Robustness, what it means? Property associated with massiveness of concrete. Again, it is very important property and big advantage of concrete. You can use, like the example of robustness is gravity dam, concrete dam. Huge amount of concrete is used in that particular work. Bridge construction, bridge piers, underwater structure, and easily we can work with concrete. So that mass construction work is possible with concrete only. And that property or that advantage is known as robustness. Clear? And last is it can be designed for desired property by changing the proportion of the ingredients. Like if we want to plaster a building for surface smoothing, change the proportion, eliminate aggregate, and that particular concrete is known as mortar, but it's nothing but the concrete. Then for construction of beam column, add aggregate, then it is also concrete. In construction of bridge, canal, yes, everywhere. So by changing the proportion of the material, you can get the desired strength, desired shape, everything. And it is used everywhere by changing the proportion of ingredient. So it is most advantageous construction material. So which are the disadvantages? First, as we know, low tensile strength. Again, this disadvantage can be eliminated by inserting steel reinforcement, right? So, low tensile strength, low ductility. Again, this disadvantage can be eliminated by inserting steel. It is ductile, it is brittle, so not much capable to deform, right? Before failure, like unlike steel. These disadvantage can be overcome by adding the additional materials. So we can say it is totally advantageous or very important material in construction. Now let's start with the materials used in this topic. Concrete material, this is module 2. In this module we are going to study about the concrete making material, their properties, and to find out that property, the test perform, laboratory test perform to find the material property, right? These are the important topics which are to be covered in module 2, concrete making material. Let's start with the aggregate, right? Aggregate include coarse aggregate means gravel and fine aggregate means sand, right? So we are discussed gravel means coarse aggregate and sand in topic aggregate, and then Next is cement, water and admixtures. What is aggregate? Crushed or uncrushed materials derived from natural or artificial sources, as in the form of boulder, gravel, or sand, for production of concrete are known as aggregate. So, aggregates are available naturally or artificially. Natural aggregates are boulders and gravels, sea sand, right? Are the example of aggregate. Aggregates occupy 70 to 80% of the volume of concrete. So maximum part or the main component of concrete is aggregate. Aggregates were considered as chemically inert material, but now it has been recognized that some of the aggregate are chemically active, and also that certain aggregates exhibit chemical bond at the interface of aggregate and paste. So this is the property of aggregate, means it exert chemical reaction with the cement paste. Some of the aggregates. Aggregates should be free from wild acids, alkalis, and inorganic materials. Let's see the classification. So, first we have covered the definition and the percentage of aggregate in concrete. Let's classify it. Aggregates can be classified in different manner. Let's see, based on weight: normal weight, light weight, heavyweight aggregate. Now let's start with normal weight aggregate are of two types: natural normal weight aggregate, artificial normal weight aggregate. Natural derived from riverbed, mountain quarry. Artificial man-made like flash, air-cooled slag, right? These two types are the normal weight aggregate. Now, almost all natural aggregate materials originate from the bedrocks. And as we know that rocks can be classified into three ways or three types: igneous, metamorphic and sedimentary. So the aggregates from igneous rock. Bulk of the concrete aggregate is igneous in origin, which is the main aggregate and are very strong in nature, and the example of igneous rock is basalt and granite. So these are the classification of natural aggregate based on the types of rock, right? High strength, very hard and tough. An example is basalt, granite. Second types of rock sedimentary rock. The aggregates from sedimentary rocks are limestone and sandstone. They are having less strength compared to igneous. And third is metamorphic rock. Types are quartzite, right? They are very in thin film type. They are very weak and generally they are not used in concrete making. So natural aggregate based on igneous rock, sedimentary rock and metamorphic rock. Next classification based on size. Size, the classification are coarse and fine aggregate. Coarse aggregate means the aggregates retained on IS 475 mm sieve. Retained means not passed. And fine aggregate passing through 4.75 mm sieve. Right? Now, the size of aggregate is very important. The size results in reduction in the cement content if the aggregate size is very high, and as we know that 70 to 80% of concrete mixing is of aggregate. So if large size aggregate are used in concrete making, then it reduces the cement content and reduced in water requirement, and it become dry. The concrete become dry and it reduce drying shrinkage. So size matter a lot. The maximum size of aggregate that can be used in any given condition may be limited by the following condition. So how we will select the size of aggregate? For that, we have to see thickness of section, where it is placed, whether it is beam, column or dam, right? So based on this section, the width of beam and column, based on that we can select the size of aggregate. Second, spacing of reinforcement, the distance between two steel, it can also help to select the size of aggregate. Clear cover can also help in size selection. Mixing, handling and placing technique, whether it is hand mixing or machine mixing, handle with normal conventional method or with machine, place, how it placed, location of component also affect the selection process. Now the criteria is maximum size of aggregate should be less than 1/4 of the maximum thickness of the member. Now, so based on size, fine and coarse aggregate. Next, based on shape based, there are 4 types: rounded aggregate, irregular aggregate, flaky and elongated. Rounded means pure rounded, and that type of aggregates are available naturally on river or seashore bed because water is continuously flowing over it. Similarly, if wind blowing over it, then sandstone, then the gravels, right? The fully water worn or completely shaped by attrition are rounded aggregate. So river bed માંથી જે aggregate મળે છે are known as rounded aggregate. Irregular, which are not rounded in nature, irregular in nature, right? Pit sand, gravel are example of irregular aggregate. Flaky means thickness is small relative to width or length. One of the dimension is very large compared to other. Laminated rock. In elongated rock, mean size is equal to mean thickness into 1.8. So flaky and elongated aggregates, thickness is very less compared to other dimension like length or width. Next classification based on density. Lightweight aggregate density is less or equal to 1120 kg per meter cube. Normal weight aggregate density is equal to 1520 to 1680 kg per meter cube. Heavy weight aggregate density greater or equal to 2080 kg per meter cube. Now, last classification of aggregate based on mineralogical composition. If the silica content is more, then that aggregate is known as siliceous. And if clay content is more, then that aggregate is known as calcareous. So this is the classification of aggregate based on density and mineralogical composition. Let's start with the properties of aggregate.